I'll go to the code first. So yeah, this is the character player. He has a character controller component. Yeah. So my entire engine is based on the ECS system, and every entity has a bunch of components attached to them, and all the components are managed by these systems. Yeah, so go over the physics part. Physics is provided by the bullet physics engine, and all of them are implemented using these interfaces here. So basically, the rigid body has this interface. The rigid body class just implements all of these methods. So here, rigid body basically just implements all of these methods. Right, and then the physics system. Right, and the physics system implements the collisions, and it also implements like the character controller for like the player. So all of the player movements are controlled using this character controller. Also, all systems they basically implement this process method to implement all of their uh, things during the update loop. So we set the gravity. This is adding the character controller to the world. This basically activates it. So here we calculate all the positions at the rigid body end. And then every frame, bullet physics gives you this position and rotation, which you can assign it back to your visual character, basically. This is the stuff for the character controller. The character controller gives you a matrix. So this matrix, you can just assign it back to the model matrix, and then you can just decompose it to get all the components like position and rotation and everything. What is that? Yeah, basically over here. So this matrix that you just get this matrix from bullet physics, and then you just decompose it into the position and rotation and the scale, of course. So yeah, now on to the animations. So the animations are loaded with async library, of course, and they're all FBX animations. The place they're getting loaded is right here. This is assigning all the animations to the specific animation components. So for example, this is the player component, so it has these three animations assigned to him. And so if the player is walking, running, or anything, it just plays these animations. So this is the loading part. I'll go into the animation class. This is the animator that actually like plays the animation and calculates the bone transforms, the matrices for each bone. Then at the end, you just get this matrix that has so it is the bone ID versus the matrix for each bone. So you just assign that in the shader. One sec. Yeah, so before you draw them, you just assign these bone matrices in the shader, and you'll be good. This is where we calculate the bone transform every frame. So whenever like we change an animation, it just switches to the new animation, resets the current time, and plays the new animation. Also, like during when it is like switching animations, it also blends them, um, blends between them, and then you can get this. So it takes this transition time to like change from this animation state to the next animation state. And then it blends smoothly between them over here. And then at the end you get this transformation matrix. Right, so And then this is the animation component. So these are the three animations that a character can have. And this is the bone data. Initially, all the animations are like just an idle until something triggers it. Right, next, then moving on to the AI. Right, so go the AI component first. Yeah, so these AIs have, they can implement all of these behaviors, but the states only have like, there's only like three states in the game. So it uses the pursue state, the catch state, and the idle state. Initially, all of them are on like idle state. The interface for the state class. Yeah. Then in the AI system, that is the speed and the velocity for all of them. And then now go in the AI system. So the AI system, it has this state pool class. So every frame it will just create a new state, right? So you don't want that, it will be inefficient. So and the state pool, it just generates a bunch of states at once, and then you can just like get that state and then return it back to the state pool. This happens every frame, so you don't have to worry about memory leaks and everything. Yeah, so this is the three states. Idle state. So on enter, it just does sets the initial values, and then the update, it just sets this velocity to 0 because the idle state doesn't have to do anything. And this is on exit. On the pursue state, so on enter, it just does the same thing. Then on update, it just calculates where it is supposed to face and where the player is, and then goes towards it basically. And the velocity is just set towards player into the delta time. Pursue state. So catch state is the interesting part. The enter is the same. So in the update part, you just like, so there's a timer for catch. So whenever it goes into the catch state, it just like starts this timer, and then until it is over, the character is basically, it cannot move. So it is not controllable for just 5 seconds. And during this time, their HP will go down basically. And this is the state machine class, which manages all these states. Adds the transition, so you know which behavior it can and cannot switch from. The update just calls update on all the states. It sees what the current state is and just calls update on them. And this is the part where it actually sets the state. This is controlling the health of the player and everything. So if the health goes below 0, it just basically makes it invisible, and the AI becomes inactive. And if it is a control player, then you just basically die and you can't control the player again. So now it is the, yeah, if this is the AI is active, it just like checks if the player is within this radius of it, and if it is within that radius, it just like, this is the catch. So if it is within an eighth of the radius, then it just catches the player and makes him immobile. Yeah. This is a part for like the pursue state. So if it is within, just within the radius, it will just notice the player and start chasing him basically. And the idle state basically just, when it is not doing all of these two, then it does the idle state then. Yeah, it's basically just enters and then sets the current state. Now the update method for the AI. So it gets the AI components first, then it gets the players component. So this is where we set the state machine. It sets the current state, and then this is the state pool, which just generates a bunch of like states. So the constructor here, we generate a bunch, like 10 states. And the constructor here just generates 3 of these, like yeah, equal amount of all of them, almost equal. The catch timer, so 150 is 150 frames, basically like 5 seconds, I think. Yeah, around that ballpark. Yeah, set state, call update on it, and then you just return the current state back to the state pool. Once return state, it just pushes it back to the state. And get state just removes it from the state pool and then gives it to the thing to draw. Yeah, so this sets everything. So when the player's health goes below 0, so you don't need the AI to be calculated after that, so they all set to false. Right, so I think that's about it. Yeah, and the textures are loaded using a library called stb image. It loads all the textures, PNG textures, create cube texture. Yeah, so this basically stbi load. This part loads all the. This is the thing for the cube maps. So 6 images. Yeah, the up, left, right, left, whatever. Just clamp them. Right, so I'll try running this now. So for some reason, like the debug option, it just like doesn't really run the game properly because for debug it doesn't. How should I put this? Yeah, the frame rate is kind of too low for debug, and then but for release it just runs fine. So if you're getting like low frame rates on the debug part, then I think probably you'll be fine with the debug part because you probably have a better PC than I do. Because my graphic card is probably like very old. I should be able to run it fine, I think. Yeah. So this is the animation that is playing now. Now if I press Z, I can just like toggle the run animation. So you can see how it blends between these animations, right? Now it is doing the walk again. Now it is doing the. And then these are the AIs. They will just chase the player if you're within their radius. And now they're basically caught. And now I'm attacking them and they are attacking me. So they gave me a little bit of a time window to escape. So I can just escape now. They will still chase me, and then if they catch me again, we can start fighting again. Yeah, so the music is just playing with FMOD. Hopefully it is not copyrighted. Right, so you can just at some point you just kill them. Where are they? Yes. Yeah. So now this guy has died. Now this guy can also, I think, will die. Yeah. Yeah. Now this guy also died. The goal is basically just kill all of these people. Yeah. So all of these trees also have like collisions on them, so you can't pass right through them. There's also this jump plate, you can jump. The character controller manages all of this. And because my processor isn't like my GPU isn't good enough, I couldn't like draw too many objects in the scene because it was just too laggy otherwise. Right, so that is going to be it for my presentation. Thank you for listening to me.